Today, the global information technology industry has fundamentally evolved into the invisible operating system that is actively running the entire modern global economy. In the 1950s and 60s, computing was locked inside massive mainframes, strictly serving the few institutions with the space to afford it. That barrier broke in the 1980s when personal computers hit consumer desks. Processing power was decentralized, sparking an entirely new consumer market. Today, the sector has expanded so rapidly that economists struggle to accurately measure its true boundaries. This block represents the market strictly defined by core hardware and software. Under this narrow definition, it's valued at $1.6 trillion. But zooming out to include telecom and digital services, the 2026 valuation explodes to $14.39 trillion. That discrepancy exists because IT is no longer a mere vendor service. It is the mandatory infrastructure layer required for global banking, healthcare, and manufacturing to function. This infrastructure is expanding at an 11% compound annual growth rate. Based on current trajectories, forecasters expect the total market to reach $36.8 trillion by 2035. Capital will not flow evenly across this space. Investing blindly in broad tech indexes carries risk, as specific subsectors will inevitably cannibalize others. To understand exactly where this capital is moving, strategy leaders must deconstruct the global IT economy into a four-tier architecture stack. Mapping historical capital flows and emerging disruptions across these specific layers allows for a precise analysis of which sectors are positioned to capture that $36 trillion over the next decade. The bedrock of this model is the physical layer. This consists of servers, networking devices, and immense physical data centers that process every digital action. Despite the digital economy's virtual appearance, its maximum output is limited by the availability of physical computing power and connected IoT devices. Within this layer, the global supply chain has a critical bottleneck: the manufacturing of semiconductors. The specialized silicon wafers fabricated here are in such high demand that the industry alone is approaching $1 trillion annually. The demand for these physical chips is being driven by the massive computing requirements of the next layer up the stack. Because every other layer of the stack relies on this physical substrate to execute, the production capacity of these semiconductor fabs acts as the primary physical regulator for the $36 trillion digital expansion. That physical power fuels Tier 2, the infrastructure and application layer. This is where raw computing force is converted into usable digital environments. Over the last decade, enterprises stopped buying their own on-premise servers and began renting computing power from centralized data centers. This data overlay tracks that transition. Currently, over 50% of all global enterprise computing workloads have migrated entirely off-site and into the cloud tier. Most large organizations now use a hybrid model, keeping highly sensitive data on private servers while utilizing public cloud infrastructure for scalable processing power. Sitting on top of this cloud infrastructure is enterprise software. The market is dominated by this software as a service model, where applications are licensed centrally instead of installed locally. A handful of massive companies, primarily Microsoft, Amazon AWS, and Google, control this entire layer through ecosystem lock-in. By driving the shift to the cloud and SaaS, these tech leaders transformed enterprise IT from a periodic capital expense into a permanent operational subscription. Managing these subscriptions requires human capital. Welcome to Tier 3, the execution layer. This level is powered by millions of workers distributed across key geographic clusters. This global network of IT services, consulting, and outsourcing is expected to be a $1.2 trillion market by 2026. The labor is divided by geography. North America operates as the primary driver of capital, capturing the bulk of global cloud innovation and AI funding. Europe serves a distinct regulatory function. They lead the market in establishing enterprise compliance frameworks and enforcing data privacy standards like GDPR. Meanwhile, the Asia-Pacific region, specifically India and the Philippines, functions as the execution engine and offshore outsourcing hub for the rest of the world. Maintaining this architecture requires scale. Of an estimated 50 million global IT workers, India alone employs over 5 million professionals to service these outsourced processes. Until recently, if a tech company wanted to scale its operations, it was forced to linearly scale its human labor force, continuously hiring offshore workers to maintain the lower tiers of the stack. That linear relationship is under pressure. At the top of our macro stack sit two highly volatile disruption vectors: cybersecurity and artificial intelligence. First, the defensive requirement. This flashing metric tracks global cybercrime damages, projected to reach $10.5 trillion annually. This forces organizations to pour immense capital strictly into defending their infrastructure. Second, there is a severe automation risk facing the 60 million IT workers projected to be in the market by 2025. This risk comes from the development of agentic AI systems, autonomous models designed to execute multi-step workflows without human intervention. Because of these models, the industry is already shifting away from labor-heavy business process outsourcing in favor of AI-driven automated services. As this AI vector matures, it threatens to cannibalize traditional entry-level IT jobs. The software is built to replace clusters of human labor in established offshore hubs. This transition suggests the macro valuation of the tech sector continue to surge, even as the traditional link between industry growth and job creation weakens. Projecting this assembled model forward at an 11% compound annual growth rate tracks the industry toward the $36.8 trillion mark. The physical and cloud layers scale to capture majority value, while the human execution layer remains flat. This trajectory is visible in corporate behavior today, with over 89% of organizations worldwide currently executing digital transformation strategies. Enterprises are continuously migrating their remaining on-premise systems to the cloud to cut operational costs and improve scalability. This scaling tech infrastructure forces secondary disruptions across separate industries. AI-driven diagnostics are altering the economics of healthcare, while decentralized fintech networks are redefining global banking. The leap to a $36 trillion valuation will be captured by the companies building the foundational infrastructure and the autonomous AI models. Legacy service providers relying on human labor pools are vulnerable. For enterprise leaders, the immediate offensive strategy is clear. Capital allocation must be directed towards integrating AI systems and securing scalable cloud infrastructure. On the defensive side, that infrastructure must be hardened. The sheer scale of global cybercrime makes security a survival requirement. To address the talent shortage, the human workforce must be upskilled away from redundant maintenance tasks and trained in fields like data science, cybersecurity, and cloud architecture. Organizations that fail to understand the architecture of this evolving stack risk losing their competitive edge in a purely data-driven global economy. The global IT industry is no longer a support function. It is the digital architecture upon which every other sector must now be built to survive.